This time I'm going to talk about change events. Now, change event is anything that basically affects the program. Change events can shorten a program or they can lengthen the program. They change the amount of work that has to be done and can be down to a whole heap of reasons. Typical things, lack of information from clients' consultants that prevent you from making progress. Unforeseen events such as things like the COVID lockdown that we've got currently at present. Changes in scope or scope creep, basically variation works, or delays in supply of materials or labour and waiting time for things to arrive on site. The programme is the life story of the project. So anything that changes the story needs to be recorded in order to show the effect. The reason why is very simple. Change costs money, and if the project takes longer to complete, you increase both cost and risk. Cost of running the site and risk of not getting paid for it, plus the risk of having to pay penalties for a late finish. Consequently, getting the story right can mean the difference between being the one receiving the money or receiving the payment and the one making the payment. So I'm going to show you how to track the changes and show the effect. Now, I've set up a sample program here. As you can see, it's got a very clear critical path. I've added a few things that might not normally be showing in terms of this. You can see I've got the expected completion date, which in this example is 24th of September. And I've also put another line in with a milestone that just says basically initial completion date. This is so we can track the change when I show you the changes, just to make it easy for you to see. Now, I've also, in this example, I've put in a couple of events, and I'm going to show you how to track how you would knit these into the program to track the changes. Now, there's a couple of things I also want to do before we get started, but I'll just draw your attention to this column I've put here, which is the total slack column, and this is just showing the amount of slack on each task. So as you can see, this task has got 4 days of slack. Critical path tasks, which are shown in red, have 0 slack. These tasks down here in a different chain of work have got 18 days of slack. Now, what I'm also going to do in this, which I don't usually have showing, is I'm going to install link lines and show those so that you can see the relationships between the various tasks. And I'm going to set a baseline. And the way you set a baseline is to go into the project tab, and there's a button here that says set baseline. Okay, and I'm going to set the baseline for the whole project and click OK. Now, you don't see anything actually different here at this point, because until I turn on the baseline in the view, in which I do by going to format, you won't see it. So in the format tab, this is where you turn on and off baselines to show them. So as you can see here now, baseline is showing. And all the baseline is basically a snapshot of the program at a given point in time that says these tasks started and finished here, and it allows you to go back at a later date and see how things have changed against your original snapshot. So this is a snapshot of the program at the start. I'll turn this off now, and then when we've made some changes, we'll go back and look at it. Right, so first thing we're going to do is look at this change event, and there are basically there's 2 types of events that cause issues. Things, when you're in the process of carrying out work, things come to light that you didn't know, and the way they affect the program, there are essentially 2 ways that they would affect the program. They'll either affect the task that was happening at the time you discovered the problem, and whatever the problem is, and in this case, we'll say, make the example, let's say all of this is about civil works and putting foundations, etc. So Typically an event, if this was cut to fill across site and you discover, say, a soft spot. Now, the effect can either be that it will stop this job in its tracks and the problem will have to be fixed before you can carry on, or the job itself can carry on and the work will affect the later task. So if this was being excavation across site to reduce levels and say we hit a big soft spot, then the soft spot could be treated in that instance as an isolated section of work. The remaining cut across the site can carry on, and it only affects this task, the task following. So these works can carry on. This work has to be completed before this task can carry on, so it'll affect this task. The other example would be, say, where you've got the same soft spot, but this time you're in the middle of cutting foundations, and the foundation work would have to stop until you fix the soft spot before the foundation works could carry on. So it literally would split the tasks. And we'll look at that in this example here, just to show how the two impact things. Now, whatever or whenever an event happens, something happens that is unforeseen, or there's a change or whatever, you hit a problem. So in this case, as I say, if we're assuming that this is excavation across site, basically 5 days in, you find the soft spot. So you immediately flag it and you ask a question of the engineer. So you raise a request for instruction, because under your contract, you're not supposed to carry out any works until you've been instructed to do so. I know in practice that sort of doesn't always happen that way, but so you raise an RFI and you milestone it as a flag event. So it's just basically on this date, so many days into this job, we hit a problem. You then have to wait whilst the client and his engineer comes back to you with an answer telling you what you need to do. And that becomes waiting time whilst you're waiting for an instruction. So you log it, because essentially you're standing waiting for an answer. Now, eventually an instruction will turn up, and that comes in as another milestone event as when it's issued. And then whatever you're being instructed to do, and in this case it would typically be to over excavate and import clean fill and compact it, or import hard fill and compact to fix the problem. So the resources you have on site, the excavators or whatever, currently on site, they're 100% committed to carrying out the works under contract. So any additional work requires additional resources, and you can't immediately ring up and say I want a 20-ton digger here in the next 10 minutes. You have to wait for mobilization of equipment to become available, for it to arrive at the site and be delivered. Likewise, any materials or fabrication work that's needed, it's all lead-in time to being able to actually carry out the work. And the way you would show it is, I mean, I've got here 10 days lead time for fabrication or availability of materials or whatever, and likewise you've got a lead time for mobilization of resources. So they are part of the story. You knit them into the story, and these things have to arrive on site before you can actually carry out the works. So the work itself in this instance is only 4 days work, but it's taken 13 days from when you discovered the problem to this point where you can actually repair the work. Now, as you can see, the original excavation work has been able to carry on. The impact, as I say, comes to this task, because this is the task following the excavation work, and obviously now this task has to follow this work as well. So if I just open up to show the predecessors and successors, this task now is not only following on from task 6, it's also following on from task 13. So we either entered it there as an additional predecessor, or we put it here as a successor. That successor of this task is line 14. So By doing that, we now knit in this work, and you can see now the critical path has flipped over onto this chain of work. And the reason for that being, as I said before, these works that were originally the critical path, these works had 4 days of slack. This chain of work has taken 17 days, so effectively we've taken away the 4 days of slack and we've added 13 days to the finish date, because now this is the new critical path. And the critical path is basically, it's the longest chain of jobs that have to be completed one straight after the other without any gaps, and that longest chain creates the shortest possible time you can do the work. So now we can see that our finish date is now pushed out from the 24th of the 9th to the 1st of the 10th. And the work has essentially added, and it hasn't added 17 days, you'll notice, but it's actually added, because this work was carried on, it's only added the time that's pushed out from when this task would normally have started. And if I just turn back on the baseline for a second to show that, you can see here now that this task should have started here. So we've got 1, 2, 3, 5 days, that's 8 days. It's added 9 days to program. So it's added 9 days to finish. That's the net effect of how much is pushed out. Now if I just reset this to take it back to our starting point, and I'll turn off the baseline again and close this up, and then we'll have a look at this second example. And the second example is very, very similar. A number of days into this task, the problem arises, and as I say, if we use the example as I was talking about before, where this could be excavation of foundations, and 3 days in we find that there's a soft spot in the foundation trench which will need to be filled before we can carry on creating the foundations. So I'm just going to highlight this as just to highlight this task so you can see what's happened. Now, as I say, we issue an RFI, and in this case the RFI is sitting as the job originally started on the Thursday. We're now on the Monday. We raise a flag to say here's the problem. We've then got waiting for an instruction, instruction received, lead time for additional works, for fabrication, etc., mobilization, and then performance of the work. So in this case the works is again 4 days. Now the effect is all going to be on this task that I've highlighted here. So what we actually have to do at this point is we have to knit this work into this task and show the effect on this task. So what I'm actually going to do here is I'm going to copy this line, this task, and I'm not just, you note I'm not just copying the title, I'm actually copying the whole line. So I'm copying the whole task, and I can either do that by pressing Control and C to copy the line, or right click and copy. Now what I'm going to do is I'm going to insert it at this point, and I'm going to paste in exactly the same task in place. So now I've got 2 copies of the same task. You can see they're both 8 days, they're both highlighted. And the way I knit in the effect is this task now was 3 days, or in fact is it 2 days, 2 days in before this problem was found. So I've got essentially the task is now going to be split into 2 parts. So if I call this before the problem, and this will be task 34, balance of work after work after the fix or after fix. And I'm just doing this so that it makes it explicit about how it's going on. Now you notice that because they're copies of it, they carry the same links. So these are both affecting the program in exactly the same way at this point in time. Now what I'm going to do is I'm going to split down to take this into account. So there was 2 days of work before the problem, and the balance of work in the 8-day task would be 6 days. And because this is now before the problem, and this is a direct follow-on, where so this issue now links to line 43 being the problem, and you can see now that the link line is going to show there, and the balance of the work has to follow this task. So we knit in now the balance of the work is now line 50. So I'm overwriting the original link from the copy, and it puts it in there. So that now moves it through. So there's the 2 days work that was done prior to the problem, and then here's the 6 days balance of work after the problem is fixed. Now you can see it's pushed out the program, and if I turn on the baseline again, you can see it's pushed out the baseline by quite a way, but you notice it hasn't changed the critical path. That's because this originally had I think was 18 days of slack, and even though this work has taken up all of this time, the effect is that basically it hasn't chewed up all of the slack in the job, and the job actually still finishes with what looks to be a day of slack. Now what I'm just noticing here is that this is saying 23 days, and we were just talking about 17 days. The reason for that is that when I copied and pasted the task in, it automatically indented under this section, and to get the true effect of this section of work, I need to outdent it just to take it out of that summary, so it's not actually a subtask of this work. And that, as you can see there, then the net effect is 17 days, which is exactly as I said. Originally we had 18 days, and now it's taking up 17 days, which leaves 1 day difference between the amount of slack that was in, and so we have 1 day left of slack in this job. Now this now makes this chain of work very close to critical path, and any other delays on this on these works, if they don't happen now in exactly this chain of relationships, if a job takes a bit longer or doesn't start, it will affect critical path and start pushing out. So whereas this previously had very little impact on critical path, what this variation has actually done is bring it much closer to critical, and therefore much harder ingrained in the risk of the job. This chain becomes much more risky because any delay suffered now by the contractor will push out, and if it's delay caused by the contractor, it won't be claimable as extension. It will be impact or delay caused by contractor, which is not claimable. Now, in terms of contract admin for tracking all of this, I'll just show you how I would track these events in a way that basically allows me to pull them up very, very quickly, allows me to track anything that I'm waiting on and what the root cause is. If, say, for instance, this waiting for instruction turned into 10 days of waiting time, then all of a sudden, obviously, this is now pushing critical path. But it's very, very clear here that we're waiting a long time for the client's engineer to come back with an instruction, and it's increasing our standing time, and that is claimable. So I'm always tracking when these RFIs are open before an instruction comes in. I'm always tracking how long it takes to respond, because that has a direct impact on program. And the longer the engineer or the client's architect or whoever comes back to give us an instruction, the longer the waiting time, the greater the impact on program and greater the risk of pushing out. So if I now just insert another field or another column, it's one that I've set up specifically for purpose to track RFIs and CIs. And the way I would track them is when an RFI is opened, in other words, we've raised the request for an instruction and we're waiting, it would be recorded just against RFI 21 in this case. And that way, any open RFIs are captured very cleanly as an RFI. Once an instruction comes in, I would record it like this. So basically, I've got the RFI number, and then I've got the subsequent CI number as well. In this case, it is CI06. So both numbers would be picked up in this column. So when I'm filtering, you can see here now I've got an RFI 20 with CI06, and I've also got just RFI, which is just a plain RFI. This tells me that this RFI, and I know it's the same in this thing, but essentially whatever RFI I've got that doesn't have an accompanying CI number, I know is open and still waiting for an answer. So it allows me to, at the end of the month, when we're doing reports for project control group meetings and reporting on progress, I can show very, very quickly outstanding RFIs that are still waiting on an answer, and we can prompt the client to get his act together and give us an answer. And you just notice in there I put the wrong RFI number against the other one. So I'll scroll that down, and this is in fact RFI 21, not RFI 20. And scroll them down. Now by doing this, it allows me to filter. So I can, as I say, I can filter only to show information I want. In this case, all I want to show is the variation works, the CIs and RFIs, and any effect. I'll just turn off the baseline. So we can show, and as I've gone into other videos, we can filter for anything. It just makes finding the information and tracking the information fast and quick and easy. Right, that's it. As always, if you've got any questions over this, or you want to know anything, just message me on LinkedIn or send me an email and I'll come back to you on it. And if there's anything you'd like me to create another video about, something you don't quite know how to pick up or whatever, drop me a line. As always, hope you found that helpful, and I'll leave it there.